Process mining is a discipline that bridges data science and process science. It takes event logs, digital footprints of real activities, and transforms them into visual process models. Think of it as an X-ray for your business operations, revealing how work actually flows compared to how it's supposed to. An event log is a structured record where every row represents one event, something that happened. Each event belongs to a case, has an activity name, and carries a timestamp. Together, these three elements let us reconstruct the actual sequence of steps each case followed through the process. A process variant is a unique sequence of activities observed for a case. If two cases follow the exact same steps in the same order, they share one variant. In practice, processes with hundreds of thousands of cases can produce anywhere from a handful to thousands of distinct variants. The Pareto principle, the 80-20 rule, shows up strongly in process mining. Typically, a small number of variants account for the vast majority of cases. The remaining variants form a long tail of rare, often problematic paths. This concentration tells us where to focus standardization efforts. A directly follows graph, or DFG, is the most intuitive process visualization. Each node represents an activity. Each edge shows that one activity was directly followed by another, annotated with frequency counts. It provides an immediate overview of the process flow and its branching points. Variant filtering isolates subsets of the event log for targeted analysis. We can keep only the top K most common variants to study the mainstream process, or exclude them to focus on exceptional behavior. Combined with attribute-based segmentation, this reveals where the process diverges and why. Our dataset comes from a real hospital billing system. It contains 100,000 cases, generating over 450,000 events across 18 distinct activities. These cases produced 1,020 unique process variants, giving us rich material for variant analysis. Here is a sample of the raw event data. Each row captures a billing event, a case identifier, the activity performed, the responsible resource, and the timestamp. Notice that some automated steps have no resource assigned. This is the data that PM4py will transform into process insights. The typical pipeline starts with a CSV file, which Pandas reads into a data frame. PM4py then maps columns to standard process mining roles, case ID, activity, and timestamp. Finally, the data can be exported to XES format. In our case, the hospital billing data is already provided as XES. XES is the IEE standard for event logs. It uses an XML structure with 3 hierarchy levels. The log contains traces, traces contain events, and events contain attributes. This standardized format enables interoperability between process mining tools and ensures consistent data semantics. We start by loading the XES file with PM4py.read_x's, which returns a pandas data frame. Then get_event_, attribute_values extracts all unique values for any attribute. Here we use concept name to get activity frequencies. This gives us the baseline, 100,000 cases, 18 activities. The get_variance function is the heart of variant analysis. It scans every case, extracts the ordered activity sequence, and groups cases by their variant. The result is a dictionary mapping each variant tuple to its case count. Our dataset yields 1,020 distinct variants. With the variant dictionary in hand, we sort by frequency and compute cumulative coverage using pure Python. This reveals the Pareto distribution. Just 4 variants, 0.4% of all variants, cover 80% of all cases. The concentration is even stronger than the classic 80-20 rule. Filter_variants _top_k isolates the 5 most common variants into a sublog. We then call discover_dfg to build a directly follows graph from this filtered log, and save_vis_dfg renders it to an image. The mainstream DFG shows a clean linear billing flow with minimal branching. By calling filter_variants with retain equals false, we invert the filter and keep only the long-tail cases. The exceptional DFG is dramatically more complex. Rework loops, cancellations, code rejections, and rare activities that never appear in the mainstream. This is where process improvement opportunities hide. Get underscore, start underscore activities and get underscore, end underscore activities reveal process boundaries. All 100,000 cases start with new, confirming a single entry point. But end activities tell a different story. Only 63.5% reach build. Over a third of cases never complete the billing cycle. Filter underscore case underscore size segments cases by their event count. Short cases with 1 to 4 events are often abandoned or deleted. Medium cases with 5 to 10 events represent the standard billing path. Long cases with 11 or more events average nearly 14 events and follow almost entirely unique paths. Get underscore event underscore attributes and get underscore trace underscore attributes list all available data dimensions. The hospital billing log offers rich segmentation potential, case type, medical specialty, close code, and Boolean flags like is cancelled. These attributes enable deeper analysis beyond variant-based segmentation. 3 findings stand out. First, extreme Pareto concentration. Just 4 variants cover 80% of cases. Second, a high non-completion rate. 36.5% of cases never reach the build state. Third, long cases exhibit 33.7% path uniqueness, meaning the process is essentially ad hoc for complex billing. The visual contrast is striking. The mainstream DFG on the left shows 5 clean paths through the billing process. The exceptional DFG on the right explodes with interconnections, rework loops, cancellation paths, code rejections, and rare activities. This comparison quantifies the cost of process variation. Thank you for watching this deep dive into variant analysis with PM4py. This video was built with Remotion, narrated by 11 Labs, and all analysis code is available in the project repository. Process mining transforms event data into process intelligence, and PM4py makes it accessible to every Python developer.